Congratulations on your purchase of the Bruker Elemental S1 Turbo SD Analyzer. This video was developed to help you better understand the operations of this unit and its accessories. For more information, consult your user's guide. The unit comes in a watertight Pelican case. Always return the analyzer to its case when not in use. In its case, you will find the analyzer with a battery and wrist strap installed, a CD containing the user's guide and other files for your instrument, a calibration certificate for the analyzer attached to QC data for the 2205 check sample, a flashcard containing the PDA software and calibration information. This flashcard should be stored in a safe place and only used to restore the software and calibrations when instructed to do so by Bruker staff, a 2205 check sample to confirm the calibration of the analyzer, an aluminum check sample which can be used to further verify the light element calibration of the analyzer, a kit of 5 replacement windows. These protect the analyzer from dirt and contamination, an SD card to store data, and a USB-based media reader to transfer data from the analyzer to a PC, a lithium-ion battery charger, a Hewlett-Packard PDA with user's manual, a rugged PDA cover, a background scatter plate, a USB to PDA cable to transfer data directly from the PDA to a PC, a PDA charger which can be connected to the PDA while the analyzer is in storage, 2 lithium-ion batteries, a quick start information guide for the startup of the analyzer, and a user's guide on the operation of the analyzer and its software. The PDA is the main computer controlling and operating the analyzer. In order to prepare the PDA for use, simply remove the plastic and protective covers. Store these parts in the case for future shipping protection. The analyzer and the PDA are battery-powered. When operating the analyzer, the PDA draws power from the handle battery of the analyzer. To get the maximum operating time for the analyzer battery, keep both the analyzer and the PDA completely charged. In order to externally charge the PDA, simply plug its charger into the bottom of the PDA and plug the charger into an AC line. While the PDA is charging, the orange light in the upper left corner will blink. When the PDA is completely charged, the orange light will be constant. Two lithium-ion batteries are supplied with the analyzer. Each battery, when combined with a fully charged PDA, can operate the analyzer for 5 to 7 hours. To charge the analyzer's battery, plug the battery charger into an AC line and then into the battery. While the battery is charging, the light on the charger will blink. When fully charged, the charger light will be on constantly. The control panel of the analyzer has a power button in the middle, a yellow power light to the left, which indicates the analyzer is on, and a red light to the right, which indicates that X-rays are being generated. In the front of the analyzer are a measurement window and IR sample sensor. To start the analyzer, simply push the power switch on the control panel, and then the left button on the PDA cover, which is a shortcut to the calendar button on the PDA. This will start the login procedure of the analyzer. Once the software is activated, the PDA and analyzer will connect. This is indicated on the screen. The status bar will generally shrink, giving the user the ability to log on. Tap the Log On box and enter the password 12345 and tap Continue. At this time, a radiation safety warning will be shown for about 15 seconds. If the instrument does not go directly to the Ready to Analyze screen, tap the General Purpose Measurement button to place the analyzer in the universal mode for taking general alloy measurements. After that, the analyzer goes to the Ready to Analyze screen. At this time, you are ready to make a measurement. Note, if the PDA and analyzer do not connect, you will see a message on the screen. If this occurs, you can log in and manipulate data on the analyzer, but the analyzer will not be able to acquire new data. When making a measurement with the S1 analyzer, the surface of the sample should be flat, smooth, and clean, and completely cover the window. If there is paint or corrosion on the surface of the sample, this will cause erroneous readings, and a curved surface or other sample irregularities will lower the accuracy of the readings. In order to make a measurement, simply place the analyzer on the sample, pull the trigger, and hold until the measurement is complete and then release. If light elements like silicon and aluminum are being measured, the condition of the surface finish is even more important. In this case, heavy cutting marks and coarse scratches will interfere with the measurement. If necessary, a grinder with 60 grit abrasive can be used to smooth the surface, providing a suitable surface for measurement. The IR sensor in the front of the analyzer is an important part of the safety circuit. This sensor detects reflected infrared radiation and confirms that a sample is in place in front of the analyzer. If the sample does not cover the IR sensor, the safety circuit will not allow X-rays to be generated. The red light on the control panel will not illuminate, and no measurements can be made. Once the IR sensor is satisfied and the trigger is activated, the red light on the control panel will illuminate and the measurement will begin. For certain dark-colored materials which will not reflect IR radiation, or irregular shaped materials that do not cover the IR sensor, it may be necessary to flip the front cover of the analyzer to temporarily defeat the IR sensor in order to make an assay. There is also a backscatter shutoff. This detects when the count rate falls below a preset count rate. If the sample is removed from the analyzer before the measurement is completed, this shutoff will turn off the X-rays and provide an indication for the reason of the termination of the measurement. Once the sample is prepared and the interlocks are satisfied, the final factor in starting the measurement is the state of the PDA software. There are two states where the analyzer can start an analysis: at the conclusion of the previous measurement, or at the Ready to Analyze screen shown here. If all of the conditions are met, then pulling the trigger on the instrument will start a measurement. This will be indicated by the red light on the control panel and data appearing on the screen. If for any reason the red light goes off, the measurement will stop and no additional data will be taken. Note that one cause of premature termination of a measurement is that the battery has become discharged. At this point, the yellow light should blink, indicating that the battery charge is low. If the measurement ends prematurely, one of the first actions to take would be to replace the handle battery with a fully charged one. When the trigger is pulled, X-rays are activated. This should quickly result in the display of a set of data on the PDA screen. This display will include the grade identification on the first line of the display. If there are several grades which are very similar, there may be up to 3 grades identified on this line. Below the grade is the measurement ID number. This number will be saved with the data and in the results file. This ID number becomes the internal identification of this sample. At the end of the same line is the match quality number. This number indicates how closely the first grade matches the current sample. The best possible match is a 10. Any number better than about an 8 indicates a good measurement between the grade definition and the sample being analyzed. In the bottom section of the screen is the analysis of the sample. The first column is the identification of the element. The third column is the assay of the sample. The second and fourth column indicate the expected range of the element in the grade definition displayed. The last column displays 2 times the standard deviation of the measurement. When an element is defined within a grade, the analyzed value for that element is compared with the grade limits. When the assay is within the grade limits, the assay will be highlighted in green. If the assay is outside the grade limits, but within the range defined by adding 2 times the standard deviation to the grade definition, the assay is highlighted in yellow. If the assay is outside the range even when considering the standard deviation, it is highlighted in red. The most basic type of measurement on the S1 series analyzer is a single-condition empirical calibration measurement. The empirical standard alloys calibration is the most common example of this type of measurement. The setup for this measurement is shown here. In this case, the measurement will begin when the trigger is pulled and run as long as the trigger is activated. The S1 software supports timed assay, in which the trigger does not need to be continuously activated. See the user's guide for details on this capability. The dual mode on the S1 Turbo SD will measure a sample with 2 sets of measurement conditions. The first measurement will be for about 5 seconds, then the voltage, current, and filter will change to allow the measurement of light elements, such as magnesium, aluminum, and silicon. This measurement will run as long as the trigger is activated. If the measurement is terminated before the switch to the second condition, no light elements will be reported. In order to measure light elements in a heavy metal matrix, like steel or copper, a minimum measurement time of 15 seconds is required. 30 seconds will provide an accurate analysis of the light elements. Fundamental parameters analysis is the best technique to measure any sample which is truly unknown. If you are measuring a common alloy, such as steel, copper, or nickel alloy, it is probably within the boundaries of the empirical calibration. However, unusual alloys fall outside of the calibration boundaries, and the empirical analysis may be compromised. Fundamental parameters analysis may not be as accurate as the empirical analysis, but it will provide much more accurate results for samples well outside the boundaries of the empirical calibration. For completely unknown samples and alloys such as precious metals, zinc alloys, and other less common metals, fundamental parameters analysis will give the best results. When the fundamental parameters calculation is performed, there can be a substantial delay between the acquisition of the data and the presentation of the results. This is why the first results take some time to appear on the screen, and also why the final results are not displayed immediately. In this case, the spinner icon appears indicating that the analyzer is busy calculating the results. When this happens, simply wait for the completion of the calculations and display of the data. The S1 software supports an automatic calibration selection mode known as universal mode. When the analysis is started in universal mode, the software determines the most appropriate calibration to use. If the sample falls within the boundaries of the empirical calibration, the appropriate empirical calibration will be used, and the light elements will be determined. If the alloy falls outside of the range of empirical calibration, the appropriate fundamental parameters method will be selected. In the case where the alloy is predetermined to be a light metal, that is aluminum or magnesium, there will be a slight additional delay at the beginning of the measurement, as the data acquisition conditions will be changed and the measurement restarted. At the end of each measurement, there is a slight delay after releasing the instrument trigger. This allows the assay to be calculated and the measurement conditions to be reset for the beginning of the next measurement. In the case of a fundamental parameters analysis, this time may be up to about 10 seconds. It is essential to wait for the completion of the measurement before activating the trigger for the next measurement. The best way to be certain that the measurement is complete is to look at the bottom of the screen. When the small spectra at the bottom disappears and the FP spinner is not present, the analyzer is ready to perform the next assay. If the instrument is unused for about 10 minutes, the password screen will appear. To restart the analyzer, simply input the instrument password. The analyzer will return to the exact state it was in when the timeout occurred. This timeout is part of the safety precautions, so if the analyzer is left sitting, an untrained person cannot operate the instrument. To shut down the instrument when you have completed your work, simply tap the right-hand button on the bottom of each screen. Eventually, you will reach the PDA home screen. When at the PDA home screen, press the PDA power button and the analyzer's power button to turn each off. It is recommended that while the S1 Turbo is not in use, the PDA and the analyzer battery should be attached to their chargers. There are two ways to transfer data from the analyzer. The first is to store the data on the analyzer and transfer it to the SD card with the S1 software. In order to store the data directly onto the SD card, insert the SD card into the SD card slot on the PDA. Once this has been done, go to the Utility screen. Here, tap the System Setup button. In the System Setup screen, you can choose if you want to save spectra by checking the box next to Spectra. Make sure the box next to Results is checked. Finally, check the box next to Removable Media. This will result in all the data being stored on the SD card. The other alternative is to transfer data from the PDA memory to the SD card. This is achieved by tapping the Backup Data button on the Utility menu. In the Backup menu, you can choose to copy or move the data. If you copy the data, it will remain on the PDA memory as well as creating a copy on the SD card. If you move the data, it will be deleted from the PDA memory. The destination for the move or copy is chosen in the drop-down list on the middle of the screen. Make sure to select the SD card as the destination. In addition, at this screen you will have the option to reset the sample name counter so that the next sample will be numbered 1. This is recommended for the move operation. Finally, when all settings are prepared, tap Execute. This will transfer the data to the SD card. Once the data has been transferred to the SD card, remove the SD card from the PDA and insert it into your PC using the USB card reader supplied with the analyzer. You will find a directory called Data and a file in that directory labeled results.csv. You can open this directly from the card reader or transfer the file to your computer and then manipulate it. If you double-click the results.csv file, it will be opened in Excel and you can view the data. The optional S1 Data tool can be used to open the results.csv file and view the results. Using this tool, you will be able to create carefully formatted reports for each sample which was analyzed. Thank you for your time. If you have additional questions, please contact Bruker Elemental at 1-509-783-9850 or at hhinfo@bruker-elemental.net.